Have you ever wondered if there is a place in the universe where even light cannot escape? A place where time slows down, space is twisted, and the laws of physics seem to break. A place so powerful that once you cross its boundary, there is no return. That place is called a black hole. Black holes are not just cosmic monsters. They are born from dying stars. They bend time. They shape galaxies. And they challenge everything we think we know about reality. Today, we're going to explore one simple but astonishing question. How does a black hole form? Why are they so incredibly powerful? And why do they remain one of the greatest mysteries in the universe? Let's begin our journey into the darkness. To understand how a black hole is born, we must first understand something much more familiar, a star. When you look up at the night sky, those tiny points of light may seem peaceful, but inside every star is an intense, violent battle of energy. A star is a gigantic ball of burning gas, mostly hydrogen and helium. At its core, atoms are constantly crashing into each other. This process is called nuclear fusion. Hydrogen atoms fuse together to form helium, and in doing so they release enormous amounts of energy. That energy travels outward as heat and light, and eventually reaches space and even our eyes. But this energy has another important job. It pushes outward. At the same time, gravity is pulling inward. So inside every star, two powerful forces are fighting each other. One force is energy pushing outward. The other force is gravity pulling inward. When these two forces are perfectly balanced, the star remains stable. It neither collapses nor explodes. This balance is what allows a star to live for millions, billions, sometimes even trillions of years. Our sun, for example, has been burning for about 4.6 billion years and will continue for billions more. But just like all living things, stars do not live forever. Every star is slowly using up its fuel. Little by little, the hydrogen in its core is consumed. And one day, that fuel begins to run out. When that happens, the balance inside the star starts to break. Gravity begins to win, and that moment marks the beginning of a star's death. Just as humans are born, grow, and eventually die, stars also have a life cycle, and the death of a massive star is the first step toward the creation of a black hole. Every star you see in the sky is slowly burning its fuel, not like a fire on Earth, but through a deep nuclear process happening in its core. For millions, billions, sometimes even trillions of years, a star survives by turning hydrogen into energy. But no fuel source lasts forever. One day, even the most massive star in the universe begins to change. Deep inside its core, hydrogen becomes harder to find. The nuclear fusion reactions begin to slow. The outward pressure, the force that has been holding gravity back, starts to weaken. And gravity never sleeps. Gravity has been pulling inward the entire time, waiting. As soon as the star's energy weakens, gravity begins to take control. The delicate balance that kept the star alive starts to collapse. The core of the star begins to shrink. As it shrinks, it becomes hotter and denser and more violent. Temperatures rise to unimaginable levels. In response, the star desperately tries to save itself. It begins fusing heavier and heavier elements. First helium, then carbon, then oxygen, then neon, then silicon, until finally iron. And this is where everything changes. Iron is the dead end of stellar fusion. Fusing iron does not produce energy, it consumes energy. This means the star is now losing power faster than ever. The core, now filled with iron, can no longer support itself. Gravity completely overwhelms the star, and in a fraction of a second, the core collapses. Imagine a mass larger than our sun being crushed into a space only a few kilometers wide. Atoms are squeezed together so violently that electrons and protons merge. The collapse happens faster than the speed of sound. The core falls inward, then suddenly rebounds, and what follows is one of the most powerful events in the entire universe, a supernova explosion. The outer layers of the star are blasted into space at millions of kilometers per hour. For a brief moment, this single exploding star can shine brighter than an entire galaxy containing billions of stars. Everything the star spent his life creating, carbon, oxygen, iron, gold, is scattered across space. These elements will later become new stars, new planets, and even life. But at the center of this cosmic explosion, something remains, the crushed core. What happens next depends on one simple factor, mass. If the remaining core is relatively small, it becomes a white dwarf. If it is heavier, it becomes a neutron star. But if the core is extremely massive, something far more extreme happens. Gravity continues to compress the core. There is no force strong enough to stop it. Not pressure, not atoms, not even the structure of matter itself. The core keeps collapsing, smaller, denser, heavier, until space itself begins to curve inward. At this stage, the star no longer exists. There is no surface, no solid ground, no normal matter. Only an object with gravity so strong that even light cannot escape. A black hole is born. But here is the most fascinating part. The black hole does not form because the star explodes. It forms because the star fails. It fails to hold itself up against gravity. It fails to resist collapse. A black hole is not created by destruction alone. It is created by collapse, by surrender, by gravity winning the ultimate battle. And this moment, the death of a massive star, is the beginning of one of the strangest objects in the universe. After the supernova fades, after the blinding light disappears, and after the star's outer layers are thrown into space, something remains. The core. What is left behind is the crushed heart of the star. And what this core becomes depends entirely on one thing, mass. If the remaining core is small, it slowly cools and becomes a white dwarf, a dense, Earth-sized object that glows quietly in space. If the core is heavier, gravity squeezes atoms together even further. Electrons and protons merge, forming neutrons. The result is a neutron star, a city-sized object with more mass than the sun. A single teaspoon of neutron star material would weigh billions of tons. But there is a limit. Even neutron stars have a breaking point. If the core is more than about 3 times the mass of our sun, not even neutron pressure can stop gravity. At this point, gravity wins completely. The core begins collapsing again. But this time, there is no explosion. There is no rebound. There is no known force left that can resist the collapse. The core keeps shrinking. Smaller, denser, heavier, faster. Matter is crushed beyond atoms, beyond particles, beyond anything we can describe with certainty. Space itself begins to fold inward. Time begins to slow. The core collapses into an unimaginably tiny point. This point is called a singularity. Around this singularity, a boundary forms, a border in space. Once you cross this border, escape becomes impossible. This boundary is called the event horizon. And the moment an event horizon forms, a black hole exists. Not as a hole in space, not as a tunnel, but as an object with gravity so powerful that nothing can escape. Not gas, not stars, not radiation, not even light. From the outside, a black hole looks perfectly dark, invisible, silent. But its influence is enormous. It bends the paths of stars, it warps space, it slows time, and yet a black hole is not a cosmic vacuum cleaner. It does not hunt the universe. It only consumes what comes too close. The birth of a black hole is not a violent explosion. It is a silent collapse, a final surrender of matter to gravity, the ultimate victory of gravity. And from this collapse, one of the most mysterious objects in existence is born. Black holes are not powerful because they are large. In fact, many black holes are smaller than cities. They are powerful because an enormous amount of mass is squeezed into an incredibly tiny space. This concept is called density. The more mass packed into a small area, the stronger gravity becomes. Imagine taking a mountain and compressing it until it becomes the size of a marble. The weight does not disappear. The mass stays the same. But now it is concentrated into an unbelievably small point. Gravity would become extreme. A black hole is this idea taken to the ultimate limit. A mass larger than our sun crushed into a region smaller than a city. Because of this compression, gravity near a black hole becomes so intense that space itself bends. Time slows down. Distances shrink. Even light cannot move fast enough to escape. There is a boundary around every black hole, a point of no return. This boundary is called the event horizon. Once anything crosses the event horizon, it can never come back. Not a spaceship, not a signal, not even light. From outside, we cannot see what happens beyond this boundary. The event horizon hides everything. It separates our universe from the unknown interior of the black hole. So the true power of a black hole does not come from size. It comes from compression, from gravity pushed to its absolute extreme. A black hole is not a monster that hunts space. It is gravity in its purest and most extreme form. Many people imagine black holes as cosmic vacuum cleaners, sucking up everything in the universe. But the truth is quite different. If our sun was suddenly replaced by a black hole of the same mass, Earth would continue to orbit exactly as before. Black holes do not roam space, hunting planets or stars. They only pull in objects that come too close. Their power is extreme, but it is local. They are dangerous only if you approach them. So, a black hole is not a universal destroyer. It is simply the ultimate expression of gravity. The truth is simple. Nobody knows for sure. Inside a black hole lies one of the greatest mysteries of the universe. At the very center, there may be a point called a singularity. A point so small, so dense, that the laws of physics as we know them break down. Time and space themselves are warped beyond comprehension. Nothing behaves normally. Nothing follows the rules. Black holes are a stark reminder that, even with all our science and technology, humanity still knows very little about the cosmos. They are doors to the unknown, and places where our imagination meets the limits of reality. The truth is, nobody knows for sure. At the center of a black hole may lie a singularity, a point so small and dense that the laws of physics as we know them no longer apply. Time slows. Space bends. Matter is crushed beyond recognition. Black holes are the ultimate mysteries of the universe, places where our understanding ends and imagination begins. They remind us that the cosmos is far stranger than we can ever imagine.